morning, students. Today I am going to discuss about the van der Waals equation of state. Van der Waals equation of state for real gases. Van der Waals equation of state for real gases. Equation of state means an equation one which connects the pressure, volume, temperature of the system. It's called as equation of state. Van der Waals equation of state. P plus A by V square into V minus B is equal to R into T. This is the Van der Waals equation of state for real gases. This equation, though it seems to be very simple, it gives more accurate discussion for describing pressure, volume, temperature of real gases. This equation describes the pressure, volume, temperature, PVT behavior of a real gas with more accuracy. Because perfect gas law or ideal gas law is failed to explain the PVT behavior of real gases. Why? There are two reasons. There are two assumptions. In ideal gas law, assumption number one, intermolecular forces of attraction. Intermolecular forces of attraction is assumed to be negligible. Assumption number one. Assumption number two, volume of an individual molecule is assumed to be negligible when compared to total volume occupied by the gas. Based on these two assumptions, ideal gas law is formulated. This is for ideal gas. When you go for real time or real gases, this equation is failed to explain the PVT behavior of real gases. Clear? Because of these two assumptions. This will be applicable. This ideal gas law will be applicable to the real gases subject to the condition the pressure of the real gas. If it is P tends to 0, pressure tends to 0, this ideal gas law is applicable. Unless otherwise, you have to incorporate the correction term in pressure as well as volume. Then only this equation will provide accurate value of estimation of molar volume of saturated vapor and molar volume of saturated liquid. Clear? How to eliminate these two? How these correction terms are involved in this process? Just listen. This is a container trapped a certain amount of gas. This is molecules of gas. This is molecules of gas. Always, in reality, the molecule will tend to escape to the atmosphere by certain amount of force. Force per unit area is called as pressure. Force per unit area is called as pressure. Always molecules tends to escape to the atmosphere by expensing certain force. Force per unit area is pressure. This pressure is equal to actual pressure. In ideal gas law, this pressure is always less than that of ideal gas pressure. This shortfall in pressure causes a serious error in estimating molar volume of saturated vapor and molar volume of saturated liquid, because a molecule which began in it tends to pull the molecule in downward direction. This pulling process is called as intermolecular forces of attraction. Intermolecular forces of attraction. For escapism, this molecule spend certain amount of force to counterbalance this pulling of this molecule. This force to be accountable. This force to be accountable. This intermolecular force is directly proportional to 1 by v square. This concept is obtained, this fact is obtained from kinetic theory of gases. Kinetic theory of gases. This is for 1 mole. For n number of moles, n square by v square. Hence, van der Waals incorporated this correction factor in pressure term as P A into n square by v square for n number of moles. For 1 mole, A by v square. This correction term for intermolecular force of attraction, correction factor for intermolecular force of attraction is included in pressure term. Clear? Next point. See this molecule. In ideal gas law, each molecule is assumed to be point mass. The volume of an individual molecule is assumed to be negligible when compared to volume of an total volume occupied by the gas. But in reality, each and every molecule has a different value in volume. So, volume of this molecule should be excluded because this volume is unavailable for molecular motion. This volume is unavailable for molecular motion or movement. Hence, this volume should be excluded. A correction term should be involved in volume. That is, volume should be excluded minus B. Okay, A and B are the constants of van der Waals constants. A and B are the van der Waals constants. This will be always positive. The equation for A and B are obtained from the concept of critical properties. A is equal to 27 R square T C square divided by P C square. The unit of A is Newton meter power 4 divided by K mole square. The equation for B is equal to R Tc divided by 8 Tc. The unit of B is equal to meter cube per K mole. Meter cube per K mole. A and B are van der Waals constant. Always they are positive value. The equation for A and B is given here. This is obtained from the concept of critical properties. Next, I am going to rearrange this equation. Just listen. P plus A by V square into V minus B is equal to R into T. P is equal to R T divided by V minus B minus A by V square. P is equal to V square into V minus B R T V square minus A into V minus B. Again, P V square into V minus B is equal to R T V cube. R T V square minus A into V. Minus into minus plus A into B. Upon rearranging this equation, P V cube. P V square into V cube minus P V square. This term should be in the left hand side. Minus R T V square. This term will be positive plus AB. This term will be negative. Minus AB is equal to 0. So P V cube minus of R T plus P into B into V square plus AB minus AB is equal to 0. This is cubic equation of state. So van der Waals equation is also called as cubic equation of state. It gives three real roots. Three real roots for volume. One is largest. Another one is smallest. The third one is intermediate. The largest value is volume of saturated vapor. The smallest value is volume of saturated liquid. The intermediate is hypothetical. Hypothetical. That means it has no physical significance. So Van der Waals proposed an equation in order to describe the PVT behavior of a real gas. Also, this equation is called as cubic equation of state. Cubic equation of state. This will give three real roots for volume. One is largest, another one is smallest, one more is intermediate. Largest value indicates volume of saturated vapor. Smallest value indicates volume of saturated liquid. The intermediate is hypothetical. It has no physical significance. This is called as cubic equation of state. Thank you.